Welcome back, day 3 of 4 of your review. All right, let's go continue on. So, number 48. If two polygons are similar, then their corresponding angles must be what? These two polygons are similar. What's true about the angles? The angles are congruent. If two polygons are similar, corresponding side lengths must be, oh, they're obviously not congruent because they're not the same size. They could be congruent, but they don't have to be. Similar, meaning they're going to be proportional. All right. Let's see. Given triangle ABD is similar to triangle DEF. All right. What do we know is true about these things? How do we set it up? We need first a scale factor. So look for ones that have both numbers up, 3 and 12. 3 over 12 equals 8 over 11, 8 over x. Or 8 over x equals 3 over 12. If you did 8 over 3 equals x over 12, it is okay. The key is after you set up the first step, the next step is always going to be the same. 3 times x equals 8 times 12. 8 times 12 equals 3 times x. 8 times 12 is 96. 96 divided by 3 is 32. That's pretty easy. Now let's try to find y. We're going to use the same thing. Don't use 8 and x, use 3 and 12 equals y over 17. Okay, now the variable's on top. You always go left to right or right to left. Okay, keep the same pieces, or top to bottom, top to bottom. Always do the same stuff. Don't mix things up. So in this case, you get 12 times y equals 17 times 3. 12y equals 51, and y equals a 44 and a quarter, 4 and 25 hundredths, 4.25. All right, that was pretty easy. That's similar triangles. Let's move on to 52. 2 ladders leaning against the wall. We got more ladders against the wall. How long is the shorter ladder? So they're 8 feet high, 24 foot high, 30-foot ladder. Well, to find how long the shorter ladder is, you put in x feet, right? So what do you think you use? Pythagorean theorem? No, because you don't have these. But we can use left, left, top, top, right? So you can use 24 over 8, right? Height, height, over ladder length, 30 over x. 24 times x, you cross multiply once again. 24 times x equals 8 times 30. 24x equals 240, and x equals 10. Got it? Awesome. Yeah. All right. 53. What triangle has side lengths of 3, 6, and 10? Remember, we have to do the squared. Here are the formulas we went over the other day. Right triangle, c squared equals a squared plus b squared. Acute, c squared is less than a squared plus b squared. Obtuse, c squared is greater than a squared plus b squared. And if a plus b, the two shorter sides, are not greater than c, the longer side is not even a triangle. So, take the two shorter sides, square them. Take 13 squared. 169, 36, and 100. 169 is greater than, since your c, your longest side is greater than the other two sides squared. It is obtuse triangle. Got it? Take the two smaller sides, 18 squared, 22 squared, and then you take your larger side, 26 squared. Plug it in, plug it in, plug it in. 676, your larger side squared, is less than your two other side squared. That would be a cube. Got it? Awesome. This is my good side. All right, next one. Get back in here. Measure of each interior angle of a regular pentagon. So, regular pentagon, first off, has how many sides? 5 sides. We're going to use our formula. Interior angle equals the number of sides minus 2 times 180 divided by the whole number of sides. The reason for we're doing this formula is it is a regular pentagon and all the angles are the same. So, 5 minus 2 times 180 divided by 5. 3 times 180 divided by 5. 540 divided by 5. And I think that answer is 108. 108. If we do interior, we got to do exterior, right? Find the measure of each exterior angle of a regular hexagon. Exterior angles sum is always the same, and it's always going to be 360. So you just take the number of sides of a regular hexagon, which happens to be 6, not a stop sign. All right? So this is like a hex nut that you turn. All right, so 3 360 divided by 6 means each angle is 60 degrees. 60, 60, 60. So you'd have to extend this. That's how you get your exterior angles. And the 1/808s are all these angles. In case you forgot, we just did it about a month ago. All right. Number 57. Choose the statement that is always true for any parallelogram. The diagonals always bisect each other. Is that true? Well, here's a parallelogram. Opposite angles are parallel. Opposite sides are equal. Opposite angles are congruent. The diagonals bisect each other. And then you got this whole thing going on. A bunch of alternate interior angles. And you got a whole bunch of vertical angles here. So let's see. Well, diagonals bisect each other. That is indeed true. Adjacent angles are congruent. Nope, opposite angles are congruent. They can be if it's a square or a rectangle, but not always. This has to be always true. Diagonals are congruent. Well, they can be if it's a square or rectangle, but not always. Oh, there you go. Are the angles perpendicular? Once again, in a rhombus, square, or rectangle, oh no, in a rhombus or square, they are, not in a rectangle. Got it? I don't know how these mistakes slipped in. Double check this like 5 times. All right, 58. Find AM in the parallelogram if MO, the blue diagonal is 26, if PN is 18, what is AM? Diagonals bisect each other, so it's going to be half of MO, half of 26, which is 13. That's it. Good? Awesome. 58. Find the measure of the midsegment. Midsegments of trapezoids are, do you guys remember the formula? Half the sum of the bases. So you take the sum of the base plus base, divided by 2, and you get midsegment. So my two bases here are 40 and 14 and 20. 20 plus 14 is 34. Half of 34 is indeed 17. You all right? Turn my shoulders towards you so you can see property of the tires. All right. What type of quadrilateral does not have any parallel sides? One of the quadrilaterals with the parallel sides. You know what it is? Give you a hint. It's windy, fly it. It's a kite. All right. Kite's the only one that doesn't have parallel sides. Trapezoid has at least one pair. Every other type of rectangle, rhombus, parallelogram, square, all have 2 pairs. The point A equals negative 7, 3 is translated onto A prime by the vector U 5, negative 4. The coordinates of A prime are as follows. Ready? When you do a vector, you just take the point and you add the vector to it. And that gives you your new point. So I'm going to take point. There it is. Coordinate notation for translation. You're going to add the x value. You're going to add the y value. And that will slide or translate your formula this. So this means you're going to go 4 to the right, 5 to the right, 4 down. Or you're going to take negative 7 plus 5, 3 minus 4, and get your new vector, which is 2, negative 1. Right? Good? Any questions with that? Sorry, I lost my pointer under my TV. Next problem. Circle is a set of all points in a plane that is the following. Does a circle have is it a set of points that have a center? No. There's a center to a circle, but it's not a set of points that have a center. Are they equidistant from a given point? Are all these things the same distance away from a given point? What do you think? That is correct. You know why? Because that equidistant distance is called your radius. Okay, if you circle, you have a radius. If you spin your radius around a circle, you get all the points. So these are all just an infinite number of points. It's like a compass. Spin it around. Are they a set of points that have a diameter? No. The diameter could also be chords. Okay. And does it lie within a given radius? No, it doesn't. It lies on the outside of the radius, not inside. So you have to be careful of what the questions actually ask. Got it? So even though most of these are true for a circle, it's not true for the set of points on the circle. Got it? You gotta think. All right, 63. Which transformation is not isometry? I can never say that word right. What that word means, anyway, is it does not change what? Isometry, yeah, I'm going to go isometry, means the shape does not change, okay? So, for instance, a translation, a reflection, a rotation are types of isometries. A dilation is not, all right? So, first one. Does the figure change? No. Oh, there you go. Size not change. This is just simply rotation. You're rotating it, probably about 270 clockwise. What about B? Does the size change? Yes, it does. So that one is dilation. What's this one? Kind of stretching it, right? No, this is actually rotation. If you rotated this, it looks like that. What's this one? That's a translation. So, which one don't we like? Boom! Oh, this is also reflection. The dilation. The dilation, the size changes. B is not asymmetry. Right? 64. If a circle has a circumference of 65 feet, what is the radius? Circumference is 2 pi r. We did this with circles. So 65 equals 2 pi r. We divide this by 2 pi. When you divide something by 2 pi in a calculator, make sure you put the 2 pi in parentheses. So 65 divided by open parentheses, 2 pi button, close parentheses, gives you your answer of 10.3 feet. Right? Right? Almost done. Find the length of a 70-degree arc in a circle with a radius of 12. Remember the formula for this? Formula arc length equals the measure of the arc over 360, because you want the percentage, times 2 pi r, which is your circumference. All right, so 70-degree arc, 70 divided by 360, 2 pi times 16. And it says leave it in pi form. So that means don't use the pi button. So when you do this, 70 divided by 360 times 2 times 12, it's 4.7, and then the pi button. That's it. If you did not put it in pi form, you had 14.8, but say it was multiple choice, all the answers are like this, we'll just type in all your answers into the calculator to see which one gives you 14.7, right? Duh. All right, 16.6. Automobile, otherwise known as a car, has a 24-inch, 2 dashes inch, diameter wheels. All right, that means that the wheels are about 2 feet across. If the wheels revolve 5 times, so that means they go around in a circle 5 times, after the brakes were applied. First of all, that means you got bad brakes. Then the stopping distance would be blank. All right. Now, if you want to find distance, it's the number of revolutions times the circumference of a circle. All right. Remember, we did this with bike tires, with skateboard tires, with car tires, all that fun stuff. So the distance is what we're looking for. Number of revolutions we got. Now we need the circumference. So it's pi times diameter, or 2 pi r. The diameter is 24, so it's pi times 24, or 2 pi 12, gives you 75.4 inches. So we're good here. Number of revolutions is 5. Stopping distance, 74.5. Distance is 377 inches. Do you even know what that is? No, that's, you want to turn this into feet. How do you turn inches into feet? Divide it by 12. 377 times 1 foot to 12 inches gives you 31.4 feet. Is that good? That's really bad. That means if you slammed on your brakes, it would take you 31 feet or 10 yards. All right. Which is probably about the width of our classroom to stop. Ugh, that's probably going to smash into something. So fix your car. Well, all right. Last 2 problems. This one's a little tough. Find the area of the following gasket. All right. Now, way to find the gasket area is very simple. Area of a circle is pi r squared, right? So we need to know the area of the yellow because the white stuff is not there. All right. So there's a hole in it. So we're going to take the area of the big circle, subtract the area of the little circle. So pi r squared, we need to know the area of the little circle and big circle first, but all we have is this 10.4 and this 3. So first thing you have to do is you have to find out what the radius of the inside is. So if the diameter is 10.4, the radius is half of that, which is 5.2. Half of 10.4. So it's 5.2 from here to here. So the radius of the large circle is 5.2 plus 3, which is 8.2. So we use the 10.2 divided by 2 to get 5.2. Add it to 3, and we got 8.2. Now, area of the large circle, pi, r squared. That's the red circle. Area of the smaller circle, pi, 5.2 squared. You get 211, and you get 84.9. What do you do with the two areas? You subtract them. Area of the gasket equals the area of the bigger circle minus the area of the smaller circle. Because you're taking out this piece right here. 211.2 minus 84 and 9/10, and you get 126 and 3/10 square units. All right. I don't know if it's an inch, a square, meter, nanometer, centimeter, but you got the units. Got it? Wasn't too bad. All right, last one. Oh, this used to be my favorite question. What is the area of the shaded part of the figure if each side of the square is 24 feet? So here's your square. You just drilled 9 holes into that square. The first thing you have to do is find the area of the square. Each side is 24 feet, 24 and 24. All right. Area of the square is side squared, 576. We're going to have to take these out. So we need to know the area of each one of these circles. And what do you notice about those circles? They're all congruent, right? So how do you find the area? You need to know the radius. How do you find the radius? Well, each one of these circles has a diameter of what? Since they're all congruent and all 3 add up to 24, each of these diameters are the same. 24 divided by 3 would be 8. Now, since each diameter is 8, what does each radius have to be? Half of the diameter, which is 4. So now I can find the area of each one of these. Pi times 4 squared, 16 pi, which is 50.3. So how many do I have? I actually have 9 of them. So area of the shaded is area of the square minus 9 times the circle areas, because you have 9. 576 minus 9 times 50.3. 576 minus these two is 452.7. And then you get 123.3. 123.3 square units. All right? So, we're almost done. That is officially day 3 is over in the books. All right? One more review lesson. No. All right, so hopefully you get all this. Once again, we already did the Kahoot in class, and this is just a review in case you need more time to look over it. Until next time.